So right now I'm going to be talking about more of the kind of applications side for MODIS and VIIRS. These are kind of two of the very common sensors, and we'll talk about why. And I won't be getting into much of the academic material like Sean did yesterday. This is really kind of just looking at the types of data you can use and the application areas that you may be interested in. So we have a couple interactive demonstrations, and we'll try to wrap up in time to get us to lunch, okay? And if there's any questions, raise your hand. Okay, the objectives for my session here. First, understand some of the technical capabilities of MODIS and VIIRS. These are two very complementary sensors. We're going to explore some common applications for these types of data. We're going to download the data using an interactive Python script in Jupyter Notebooks. And then we are going to be turning it over to you to change that script as we discussed in the last session. We want to make sure that you can change the dates, change the area, and see what it looks like. Okay, so MODIS, why are we talking about this specific sensor? MODIS stands for, I will say one quick note is I tried to do 3 translations of this presentation. Not everything translates perfectly, but let me know if that's helpful afterwards. MODIS stands for Moderate Resolution Imaging Spectroradiometer. So this is one of the flagship sensors for the NASA's Earth observing system. It's used very widely. I think some people here, I'm sure, raise their hands who uses MODIS data? Good number, okay. Other sessions in the workshop will probably use this as well because it's very ubiquitous. So this is a primary instrument on board 2 satellites, Terra and Aqua. They were launched in 1999 and 2002. And what's really powerful about this is that they have a 1 to 2 day revisit time. So it's very high temporal resolution. And so they cross the equator and the mid-latitudes, Terra in the morning and Aqua in the evening. And so MODIS itself has 36 spectral bands, and we can show what you can do with them. And it ranges in resolution. So this is a moderate resolution. It's not super fine, 250 meters at the finest, up to 5,600 meters. What is VIIRS? VIIRS stands for Visible Infrared Imaging Radiometer Suite. This is kind of designed as the follow-on to MODIS. I think MODIS originally had a 6-year mission duration, planned mission duration, but it's still actually going. But VIIRS is the next generation. And so it extends that record. So we have a longer time frame. And so this is a very powerful sensor for looking at kind of high resolution changes for the Earth's surface. You can map vegetation, looking at water, and we'll take a look at some of those options here. Like I said, this was launched in 2011, and it has many of the same comparable type of bands that you can use, but also improves on some of the resolutions. So there's an example here from Earth Observatory showing, if you were to click that link, it brings up an article showing how it improves the estimates of fire and burned areas. This is showing that example here, MODIS from Aqua on the left, and the VIIRS from the SOMI MPP satellite on the right. So this is just estimating or looking at the progression of a fire burned area through time. So the colors refer to the different dates, and you can see that the VIIRS has a higher resolution here. So just kind of comparing and contrasting. More important, I think, for this session is really, what products are available. And so I would encourage you to go to this link in your presentations. This is the data product table for MODIS, and it'll bring up a page that is hosted on at NASA Goddard. And so I'll show what that looks like here. And you can kind of explore the different areas, application areas that MODIS can help to inform. So we have land surface temperature, emissivity, evapotranspiration, thermal anomalies, vegetation, of course. People are familiar maybe with NDVI, Normalized Vegetation Difference Index, which Sean touched on yesterday. So there's a lot you can do with MODIS, and I'll just show you one of them. So again, we're just kind of looking at the thermal anomalies / fire data set. Again, this was changed slightly from my original topic because we understood that there was interest from some of the member countries on looking at hotspots and potentially fires. So when you click on this product in that website table, you'll see the full product name here, as well as the short name. This is kind of the code for that specific product, and that's important. We'll be looking at that later in our Jupyter Notebook script. So to visualize the data, again, this is keeping in the fire theme. I'll play this video from the Goddard's Scientific Visualization Studio. And this is VIIRS fire thermal anomalies through time in a time series. And you can kind of see how these different events change throughout time and ebb and flow. So this is something that you can do. It can be very powerful. So what makes, why are we talking about this product? Why is it maybe of interest to you? And I would really note, Sean touched on this yesterday in a very helpful way. Satellite information, it's always about trade-offs, right? This is a moderate spatial resolution. It's not going to be as fine. MODIS cannot, for instance, penetrate cloud cover. So for certain applications, it may be limited, but what it's really good at is it's fast. So at mid latitudes, we can image the Earth's surface. It images a spot on the Earth's surface up to twice a day. And so this is what we call near real time. The definition that NASA provides for near real time is simply that standard products are available within a couple days. Near real time can be within a couple hours of that satellite overpass. So for things like disaster response, flood mapping, things where you want to be able to image the surface very quickly, it can be very helpful. And that goes for fires as well. So NASA has a platform for looking at kind of near real-time data. I'm providing the link here. This is, it's called LANCE, NASA's Land Atmosphere Near Real-Time Capability for Earth Observing Systems. And so, again, I talked about a couple examples here. They have a near real-time global flood product. This is something that John Bolton's lab has done in the past, looking in the lower Mekong River Basin. So again, twice a day, you can produce a flood map here. So this is showing the red pixels are areas where MODIS has identified surface water, and you can kind of quantify that extent. And this is actually something our very own John Islander will be kind of elaborating on later, how to use MODIS to quantify aerial extent of water. We also have, again, getting back to fires, there's a specific dedicated platform for looking at fires. It is called VIIRS, the Fire Information for Resource Management. And so I can bring that up here. They have this will load. They have a global mapper where you can kind of visualize the current fires based on the different satellite observations here. And so let me see. One of the things I had planned, if we have time, is to show how you would actually take this VIIRS data, this fire near real-time data, and bring it into something like QGIS. So if we have time for that, is that something to be interested to people here? Yeah, okay. So let's see, let me go back to the presentation. Oops. So let's try to work through this. I'm going to try it out. I know there's been some hiccups a little bit with the installations, but for the people in the room, was everyone able to install QGIS correctly? Some nods, see? Okay. So I have kind of two exercises here that we want to try to make time for. One is we're going to import firms' VIIRS data into QGIS to visualize it. Okay. So the first thing you need to do, does everyone have this presentation open on their machines is my first question. Yeah, okay. So the first thing you'll need to do is go to, to this first link. You need to generate a map key. This is a free step. You'll have to type in your email and I can show you what that looks like here. Oops. So it should take you to this page. And again, if you don't want to do this right now, I can show you what it looks like. And so what we're showing here is different map layers that QGIS can import natively and visualize in real time. So I'm just going to, there's actually a tutorial here. Let's see. Tutorial and examples, QGIS. This is also linked in the presentation showing you the different steps, but I'm just going to demonstrate it on my machine. And if there's any questions later, we can work through that. So you can see my map. Okay. So this is our map file that everyone should have if you've downloaded and done the Conda installation. And all I'm going to do is decide which fire layer I want to ingest here. So I'm going to do the VIIRS 7-day fires. I'm going to copy this link. One second. And then in QGIS, I'll go to layer. Data source manager and create a new layer. So this will be, I'm going to call it firms. And I'm going to paste that URL. Okay. So this is all in the tutorial. This is just showing kind of something you can do very, very quickly to analyze and visualize something like MODIS or VIIRS. And you'll notice in this URL that I've included here, it's going to ask for your map key. So when you do sign up for that, it'll send you an email and all you do is insert your own key into that URL. So I'm going to do that right now. Okay. Oops. Okay, so again, we're running a little short on time, so the steps we can talk about later, but what I've done is I've taken that data that Lance hosts in near real time, it's updated frequently to the internet, and I've connected it just right to QGIS. And I'm just going to pick one of these layers. You can see the title, 7-day fires and hotspots, as well as a description about what that entails. And I'm just going to click it and add to map. And it might take a second to load. Okay. So this is looking at VIIRS detected fire and hotspots over the last 7 days. And this is a global product. We're uploading it or doing it right from the internet and we're visualizing it here. And so this is something that you can kind of do if this is of interest to you. It's a couple steps. And any questions so far on this? Questions? Okay. Too fast, you're saying? Yeah, so I wanted to kind of do a very quick overview of this part, so we can spend more time on the Jupyter Notebook, because that is where you'll be actually downloading MODIS data using Python and changing the parameters yourself. And so that exercise I think will be helpful, and we'll have some time to talk about different products that you may be more interested in. So let's look at that now. Oh, yes, question here.
In the URL, where do you put the key?
Mhm.
Can you go back to the?
Yep. So layer, data source manager. So when you create a new web map layer, you paste the URL here. So I'll show you. So these are the different products here. 24 hours fires, 48-hour fires, 7-day fires. So I'm going to copy that link. That's what I put in the URL. And then your map key is where you insert your map key.
Okay.
So the question we had was how to actually get the map key. There is a link in the PowerPoint that links to the tutorial, and it'll bring up this website and map key here. So you can request a free map key. All you do is type in your email address, and it'll send that to you. Okay.
The link to the web is on the presentation.
All the links are in the presentation. I just brought it up in my browser to have it preloaded.
Okay, thank you.
Okay. So that was a very quick exercise. I know it went a little fast, but I wanted to make sure we have a little less than an hour left for the next exercise before lunch. So this is again the second exercise here. Is everyone ready to move on? I should ask. See some questions? Yes? Okay. We're going to move on to our second exercise. And this is where we'll be doing another Jupyter notebook to download MODIS data, to analyze NDVI, and to plot the maps. And then we'll kind of talk about how you would change that script for different types of applications. If you want to look at flood maps or thermal ranges, things like that. Okay, so I'm going to pause here for 1 second. Any questions? Okay. The first thing you need to do for this exercise, and I'll say that the example I'm going to show is already preloaded, so we can run through it together. If you want to do it yourself, you will first need to sign up for a Earth Data account. Okay. This is a platform that helps to manage Earth science data through NASA. Other presentations later in the week will be using our Earth Data account, so it's a very useful thing to have, and it's very simple to get. So you kind of click on this link. Oh, well, I already have an account, but you can type in your email and sign up for your own email and password. Okay. So are people ready to move on to Jupyter Notebook? Yeah. Okay. So again, we're going to open our Anaconda prompt. We are in our repository here with all our files. And if I'm going too fast, raise your hand, please, and I can slow down. And I'll type in Jupyter Notebook. Okay. I'm just going to navigate to our session 2A, MODIS access and analysis. Again, we have our data folder. I have data on my machine that's already downloaded. On your machine, it's not downloaded. So I'll show you how to download it to your own machine. And it also does not have the outputs here. So we're all going to do this in real time. So this is our Jupyter Notebook for the MODIS exercise. You should be able to click it. Okay. Are people following along? See? Okay. So Juan Carlos had a great comment in the previous session. You know, I tried to do a good job of annotating my code because I knew that some people may not be familiar with Python or the syntax of these programming languages in general. So I tried to show what each kind of step does here. So first thing I'm going to do is import all our packages. The first parts are just Python packages that are used for manipulating geospatial data. But down here, you'll see specific packages for MODIS. So Python is a language you can create any package you want, and some people have made a super helpful package just for MODIS data. It makes it extremely easy, and we'll show. So this should be installed on your environment already. If there's any problems, again, we can talk about it. So I'm going to run this cell, and you'll see a little asterisk here. This means it's thinking. Okay, this little warning, that's okay. So the first thing we need to do is we're going to authenticate our session. This is where when you sign up for the Earth Data account, you'll change these lines here in cell 2. You'll insert your username, you'll insert your password. Okay. I didn't show you mine because it's my password and it's private. And this is just an example here, but Ibrahim later in the week will show a similar code. There are ways to have your passwords securely on your computer without actually putting it in the script itself. But for this time, we're going to enter our username and password, and then we're going to create a session to communicate with NASA to get the MODIS data. Okay, so now we are creating our command. We're going to say, what product do we want? Okay, so some of this isn't that important in cell 3 for the people listening on the web. But right here, you'll see the short name, which is what early in the presentation. So this is a specific product. This is the code for this product, mod 13A1. This is a 16-day vegetation index. So at the end of this exercise, I'm going to ask you guys to maybe change this to something else, right? Whatever you're interested in looking at. If you want to look at VIIRS or thermal emissivity, if you want to look at water, you can change that here. We're also going to set up the parameters for our data download. And I have a note. MODIS files can be large, around 50 megabytes or so. So just be careful as we scroll down. Here's where we have our target dates. Okay. I'm looking at 2 weeks of MODIS data. You can change these dates as well. But if you make it 2 years, you'll be downloading a lot of data to your computer. So be careful. So I'll run this cell here. And you'll also notice, Granule client is not, I got an error for an import, but we can come back to that later. My example is already loaded up here, but you also notice I've included the shapefile for the La Plata River Basin. And I've printed the bounding box. So this is the four corners of that basin. So if you wanted to look at a different part of the world, these are the coordinates for La Plata. You can change that bounding box to your own area. So that's important to note. Okay. Is everyone following along so far? Yeah, okay. The next step, cell 5, this is where we actually download it. I'm not going to run this right now. I've already downloaded it to my machine because it does take a little while. Like I said, these are fairly big files. But you can see it's going to send that command up to NASA. It's going to say, it's going to check which MODIS files are available for my date range for that shapefile. And it's going to download those into your data folder. So I'm just going to show you here. Okay, so that's what it looked like. So when you run this in your machine, it's not currently on, but you should see that kind of start to download the file. It may take a little while. So this is what the MODIS files look like. These are on HDF format. So, okay. So we have our period are now downloaded to our data folder. So let's start working with them. We're just going to do a few commands here to process the data. Again, this exercise is looking at NDVI. This is Sean talked about this yesterday. Excuse me. This is a vegetation index that uses the specific relationship with lush green vegetation and how it interacts with infrared and red radiation. So I'm just going to run through this here. All I'm doing is saying, let me see if I make this a little bit bigger, actually. Is that better? We're saying, let's go to the data folder and let's find all files that have this HDF suffix on it. And then we're printing. So right now I've downloaded 9 files for this specific region. Now we're going to manipulate it. So we're going to use some of those packages we imported in the beginning. These are just geospatial manipulation packages. And we're printing, just an example, we're going to print the different bands in just one of the files. Okay, so this is what prints out. A little hard to see. And you can see within this one MODIS file, we have multiple different bands available. So we have our NDVI here, 16-day NDVI. We have enhanced vegetation index, red, near infrared bands. So these are things that you can manipulate based on your interests. I'm just going to show you how we would pull out the NDVI specifically. Okay. So we're going to extract 16-day NDVI band from the MODIS files. There's a few commands here. Like I said, I did try to annotate what each step does for those not familiar with Python. We're kind of creating an empty list, and then we're looping through each file, each of the 9 files. We're going to open the files. We're going to mask it if need be, and then return it to a single list. So this may take a second or so. Again, you can see. Okay. this is what prints out. And basically we're just saying, here's our dimensions of our final data set. MODIS 16-day NDVI from the Terra satellite. Okay. Now we're just going to plot it. So this is just an example. We downloaded it to our machine. We've done a little bit of processing in a few lines. We're going to plot just the first one to see what it looks like. Okay, this is what pops up. Are people following along on their own machines? Yeah, perfect. Okay, love to hear it. And you can see we've plotted a single MODIS file. We've looked at the color map here, typical NDVI, red, yellow, green. We've added a title. Okay, you can change any of this. People who have worked with NDVI may note something strange about the scale here on the right. NDVI typically is between -1 and 1, so we're just going to kind of fix that. So part 3, combining all our 9 files into a single one for the entire La Plata Basin. And we're also going to apply that scaling factor to make sure the values that we're seeing are between -1 and 1. So again, using a package to merge all of our files into a single object, I'm going to scale them correctly, and I'm going to then export that object into a GeoTIFF. So again, when you run this on your machine, you should be able to, it's going to think for a second. Depending on how fast your computer is, it may take a second. But when you go to your outputs folder, still thinking. Okay. Here we go. NDVI merged. Okay, so this is the product that appeared in real time when we did that command. Okay. We are then going to reproject it. All that means is we're just trying to get into a format that can play nice with the rest of our data. So this is using a utility called GDAL, very common geospatial utility. Someone wrote a great Python package for it, and now it's as easy as one line, right? So we're taking our merged file that we just created. We're creating a new file called NDVI warp. And to run this, let me close my email so you guys aren't bothered by that. Okay, I'm going to run this cell. And I open up my outputs again, and now we have NDVI warp here, okay? And the last step, I believe the last step for this. So we have merged and reprojected our NDVI raster. Now the last thing we want to do is we want to clip it to the La Plata Basin and see what it looks like. So we're just going to clip it to our plot to shape. This is our shape file. We're going to run the code. It's going to produce one more GeoTIFF and save it to our outputs folder. And let's see if that worked. NDVI clip, right? That should look familiar. I know it's maybe a little small, hopefully for the people online, they can still see, but this is our clipped NDVI. And now we just want to plot it. We will open it up here and plot. And I'm using that same red, yellow, green. This may take a second. Everyone following along? Still thinking? Okay. Okay, here we go. So may not be perfect. It's still a pretty simple plot, but this is just, you know, I really wanted to create a kind of very straightforward exercise showing you the whole process from top to bottom. How do you download the data? How do you manipulate it? And how do you plot it? NDVI extremely common for looking at vegetation. MODIS is a fantastic sensor for looking at this type of data. Hopefully people can run it on their machines. I know there may be some errors we have to work out, but what I'd like to do now with our remaining time is kind of turn it over to you guys, okay? So part 4. We want you to change the script. So if you want, you can do it right in this code itself. If you want to keep this how it is, I suggest you make a copy. You can call it whatever you want. MODIS access new. And in that copy, you can open up the script. And I've given some suggestions of things to try, right? So the first thing would be, you probably want to enter your own username and password in the script once that gets all set up, right? That may take a second. But then you can also change the parameters. Okay, so I'm just going to scroll back up here. Like I said, you can change these to any dates you want, right? Right now, this is what I have. Feel free to play with that. Feel free to play with the actual data product itself. I'm using this data product, Mod 13A. But if you recall from my few slides earlier, you can go to the MODIS website. The link is in my PowerPoint, and you can pick any one of these different application areas. There are snow cover, chlorophyll. Let's just take a look at snow, for instance. Okay, you would open this up. You would find your short name, and you would replace that short name in the script. And if all goes well, it should download totally new files. And when you do the plots, it'll be totally new plots. Okay. Does that make sense to everybody? Okay. So we can take a few minutes. I will walk around and try to troubleshoot for parts 1 through 3. Okay. And then I can move on to the end of the presentation. Does that sound good? Okay.